Okay.
So greetings, this is Kim Pond from the University of Massachusetts, and I welcome you to the third of 4 Geospatial Webinars, a series of webinars preparing for the 2013 4-H National Youth Science Day Experiment and beyond. These webinars are being conducted by members of the NAE4-HA Geospatial Task Force in partnership with National 4-H Council and Esri. Today's topic, Creating Digital Map, will be presented by Geospatial Task Force member Frank Weidman. Frank is an extension engineer with the University of Missouri. He's a member of the 4-H GIS GPS leadership team and with E-Extension. Before I turn it over to Frank, though, let's visit our itinerary. Our main objective in conducting the National Youth Science Day GeoWebinar series is to help professionals and key volunteers to become more knowledgeable so that they're comfortable to lead or train others to lead on National Youth Science Day geospatial activity, and secondly, to go beyond just the National Youth Science Day event and lead additional geospatial activities with youth. Now, this particular webinar will be focusing on extending geospatial opportunities going beyond just the 4-H National Youth Science Day. This webinar will give you a taste of how you can create simple digital maps using your own data or information readily available to the public. This process has numerous applications in education, both for you and your 4-Hers. And finally, we'll share how you can learn about additional resources and engage one another to further support your learning and your program. Now, this particular webinar will focus on showcasing how spreadsheets can be used to collect and manage data, and how you can become familiar with resources available across a variety of GPS platforms. Finally, we'll share how you can learn about additional resources and engage one another to further support your learning and your program. With that, I will now turn over to our presenter, Frank Weidman.
Well, hello, everybody. I'm working a little bit on the edge today. I'm part of a fuel, food, and fiber tour today, and just took off a little time, long enough to take care of this important task. So I'm in a new location and testing a new internet connection, and so lots of things are going to go just right. I know. So the result of this webinar, I'm hoping that you guys will be able to learn how to accurately move your location coordinates, those points from your GPS unit, to a spreadsheet. It's kind of important to get those things just right. Just transpose a couple of numbers and suddenly you're in Eastern Europe. And so we'd like not to do that. Then we're going to discover how spreadsheets can manage your map location information. You know, each point has characteristics. Each location has characteristics that we would like to put into our information base. And so that's what we're going to do with that. Learn about additional resources, and we're also going to discover other software that aids data management. We're looking at that information, and we're looking for the easiest ways to get it in there. With the new ArcGIS Online and some other software, you can take, say, the track data and move it right on over to the map without more than about 2 steps. So that kind of makes it a lot more fun than it used to be. Back in the early 90s, when I first started learning this stuff, the process was a whole lot more cumbersome. So I think we've got something that kind of worked for everybody here. And just remember that I'm available. I'm really considering conducting a couple or 3 more webinars to help folks down the line, and maybe split this task into 2 or 3 pieces and be able to get into more detail. Okay. Getting that information from your GPS unit into your computer is a real important step. And we'd like to be able to transfer that data without worrying about transposing numbers. And we can do that. If you've got the cable to connect your GPS unit to your computer, you can. There's software out there that will allow us to import those locations, and at least we won't be making the mistake. Now, you really got to watch those locations closely, because the GPS unit will, on occasion, rarely, but on occasion, record a location that is way off. You know, the statistics says that there's only about a 2%, maybe 1% chance of recording the wrong location. So we hope that we're always in the 95%, but it's always a good idea to take a look at those data points and make sure they're all clustered where we expect them to be clustered. The first software package that I'm going to kind of illustrate. Now, what I've done is I'm not working on this stuff live. I made a choice, and the choice was hope that all the technology worked perfectly, and I'd be able to share my desktop and step you through the process using live software, live examples. Today, since I'm only going to be doing this for about 20 minutes, I just made a decision to use screenshots and kind of show you the stuff that I'm going to be using. DNR GPS is a program that allows us to communicate with our GPS unit. And so when we're hooked up to the computer with our GPS unit, and then we start DNR GPS, it allows us the ability to first recognize that we're hooked up and the computer and the GPS unit are communicating, and that's shown up there right underneath the menu line, where on my example or my screenshot that I've shrunk down and blown up, you know, I've chopped it down so we can look at it closely, and you can see that it says that I've got my Garmin eTrex Venture HC hooked up to the unit. And it's kind of important to already have used your file menu and set the projection if you want to have some projected points. But that's the NAD83 UTM zone. The NAD83 is the one that we will normally want to be working with if we project the points. And then you just got to find, you go on the web and identify the UTM zone that you're in, or go to your GPS unit and change the coordinate system to UTM NAD83, and it'll tell you what zone you're in. So that's the process that we go through to make sure everything is hooked up and everything's getting ready. We're getting ready to download the points. When we hook up the GPS unit, we're going to download some points, and you can see I've got a pretty extensive set of points here. There's a couple of dozen there. The important information that we will use in every file that we create is what kind of a point it is. In this case, they're all waypoints. They're not tracks. They're not routes. And so we're going to have an identifier on that, and that's that first column. We're going to have the latitude and longitude. That's coming right out of the GPS unit. And if you're a geocacher, you know, you're kind of used to looking at those latitude and longitude as degrees and minutes, decimal minutes. The GPS unit does not actually work with degrees, decimal minutes, or degrees, minutes, decimal seconds. It actually works with decimal degrees. And it just makes the calculation to change it over to whatever display that you'd like to work with. X and Y projection, that's a calculation based on the mathematics of the curvature of the Earth and all that kind of good stuff, and the importance of getting the right UTM zone in there. And then the comment. The comment is not as important in the ESRI software, the Esri software, as it is if you're wanting to dump it into one of the a mapping service like Google Maps. On Google Maps, it uses the identifier, the latitude and longitude, and the comment. And that's all the data that it handles. The comment can be quite long, but in several lines, but that's the things that we're using. Right here, I'm going to back up one slide. If you notice the heads of the columns, we've got heads of the columns here, and those columns are a type and identifier, latitude and longitude. That's the kind of headers that we'd like to have in our spreadsheet. If you think that DNR Garmin looks a little bit like Excel, it sure does. The basics of all of our software, all of our data that we're handling, is that we're just making a big list. And here's the list we got. Excuse me. With the headers that we've got on each one of these columns, we don't want any spaces in them. So if you want to put some kind of space in there, you have to use an underscore. And if you and we can't use any other special characters except for that underscore on these column headers. So that's one of the basic things that we kind of watch out for. The software used to be a whole lot more intolerant of that than it is today, but that's what we've got. Here's a little closer look at the headers and the data. You can kind of see what we've got there, decimal degrees, and then the X and Y projection are in decimals, and they're actually meters, and that's the data that we're using. In DNR Garmin, yes, they are already there. Yeah, the headers are already there. Okay. Here's after we get our data in there, we can make a choice. If the headers that are in DNR Garmin are appropriate for our use, we can put our data right in there and save all kinds of steps in our data handling. But the chances of that are pretty slim. The reason I use DNR Garmin is to make sure that I don't transpose any numbers on my locations. And then we go and we're going to save to file. We can also load from file, and it will accept and rewrite all the file formats that we use in all our mapping software. Here's a quick look at the file manager window when we go to save. We take a little closer look at the kinds of software that are kinds of file types that we have here. We've got the ESRI shapefile, the Google KML file. We got the GPX file, and that's the one that's used by all the geocaching software. We got a comma-delimited text file. That's the one I've got highlighted, and that's the one that I like to manage my data with. And we've got some others there that are a little less used, but still very viable. The tab-delimited text file is also a very good one to manage the data. Both of those files, both of those text files, are files that we can import right into Excel and any other spreadsheet. All the spreadsheets will handle those. If we look at the data and just look at the information in a comma-delimited text file, this is what we've got. Now it looks kind of messy, but each column is separated on each line by a comma. And so you got type, ID, lat, long, Y projection, X projection, comment, and all the other information is on there separated by a comma. I just threw that in there so if you really want to look at the data in the raw format, your notepad on all your computers will give you a look at it. Here's what we do when we start bringing it in. When I go out there and open this file. I'm going out there and I saved that file, and it had a TXT on the end of it. The comma delimited. You can see that I've got the delimited dot checked there, and then it shows you the data that you're importing with that file. Yeah, I've already selected it. It started the import wizard to bring in the text file. I can click the next button, and it will take me to the next screen. And I can tell it for sure that I want it to be comma separated, and it automatically sorts all those columns out for me and creates my Excel file. And so this is what it looks like when it comes into Excel. And when it actually comes into Excel, all the columns will be identical in width. They'll just be so many characters wide, so many dots wide. So I usually go in there and adjust my column widths to fit. I use the format and expand all the columns to whatever it needs to be, and that gives me the information that I need for putting on the so that I can see everything. Okay. Yeah, I'm putting all that stuff in there. And what we've got here is my finished, what amounts to my finished data file. This happens to be the data from 2012 service project for the kids that went on the leadership team out to the San Diego conference, the ESRI conference. And this was our service project. It has all the information we deemed appropriate and Fish and Wildlife Service wanted to see. And so we've given everything a name. I've given it a serial number or identifier number in that second column. In the third column is latitude. Fourth column is longitude. We've got the X and Y projection. We've got the comment, which on these GPS units is the day that we collected the data. We can change that to whatever we like. And then I started creating my own columns. And my own columns included things like the waypoint number from the group that submitted it, what kind of a point it was. Was it a plant? Was it habitat? Was it a point of interest? And we gave it a special name. We identified the team, and there were several other things that we identified there. We actually built much of our metadata right into the data file. Here's the basics of this. Excel just creates the list for you and organizes the list of information. Each line is a separate location point. Each column is a separate attribute. So basic nomenclature for you is in Excel, we call these things headers, and we've got the headers across there. If I was to call them something more common, I just call it information or characteristics of that location. In the mapping world, we call it attributes. So it's just what we've got there to identify what we're looking at and collect all the important information for each one of those points. Okay, now we're going to save it as a CSV file. Remember, I said we're going to do that. We could also run it back through DNR Garmin and turn it into a shapefile. But the CSV file goes into all the mapping software pretty nicely, except for Google Maps. In Google Maps, we've got to use the KML file. So we're going to go through that. The CSV file. Then I go on out to arcgis.com and I sign in. You can see that I've I've highlighted the button up there for next to the ESRI logo. That it's the sign in location, and you can go in there and create your new account if you don't already have one. or you can sign into an existing one and use those kinds of information to get in on the line. And then I usually click on the My Content button, and it brings up all the information I've got, and it also lets me import, or I can go straight out and I can start creating my my map. And you can see there's a Create Map button on the thing that gives you the ability to go ahead and start your map. And then if I'm importing a particular file, I can click on that Add Item thing and bring in a file that I've created in my CSV file. The accounts that you guys will be using are the more there are not the free accounts. They're the ones that came with your software and stuff. You can still use the free accounts. I'm illustrating the free account because it uses fewer files. The CSV is the one that works the best on it, or shape file, and so I'm using that one. But you can use other files with those accounts that we may have gotten with our grant software grant, and so GPX files, Excel files, both of those work in the other website, on the more professional website. But the free one uses CSV just very nicely, and it's just a matter of going out and setting it up to upload. Okay, and so I've given it some tags, some keywords, and given it a title. And then I can just add it to my list of items there, and I can start creating my map in the map viewer. And so I end up with something that looks a lot like that shows all those points. And then if I click on one of those points, it brings up all the information on that point. Okay. So here's the software I used. I'm going to kind of wrap up now. With the ArcGIS, it really does not work with the GPS units. You have to go through a software package like DNR Garmin, or DNR Garmin is the most convenient. Or you can see on this page that I created. You can also use the Easy GPS or Garmin Map Source. I'm getting a little feedback on my system here. Okay. If you don't have the ArcGIS software, DNR Garmin will create. You can create a new account, the free account, on ArcGIS.com and operate that way, or you can use the DNR Garmin to create a KML file, and you can go to Google Maps. Both of those are free. You really need to use a program like DNR Garmin to transfer those coordinates. Okay, so here's more or less my last slide. If I've missed any questions, let me know. If you'd like to sign up for some additional webinars and trainings, you can send me an email, and we'll start planning on having some additional trainings. Okay, did I miss any other questions?
No, I think you're good. Thank you, Frank, for taking the time to be with us today. These are some really great examples and sites that youth or adults can dive right into and explore, especially with the ArcGIS being free for those that don't have the software. Before our time is up, we want to remind you of some things you should be taking action on now. First, as we mentioned in previous webinars, do plan for any media coverage for your National Youth Science Day event. Strong media coverage should be one of the primary objectives of your National Youth Science Day event. If you have not done one of these events in the past, when you register and log into the system, you'll see there is a media toolbox with sample press releases, how to go about it, and posters that you can use. Be sure each of your National Youth Science Day events are registered on the NYSD site, and get your National Youth Science Day kits ordered. They'll begin shipping out right around Labor Day, and as you saw in the beginning, a picture of what would be in the kit. Next, we want you to go to a different website, www.4h.org/my4h. This is where we'll be making the recorded webinars and other various resources available. You log into My4H using the same username, which is your email, and use the same password as you use for the National Youth Science Day site. When you go to the My4H site, search the tag Science Day, as this is the universal tag we'll be using to help locate additional National Youth Science Day related resources. It's also the tag we want you to add any resources you have to share. My4H is a site where we can all exchange 4-H related ideas and resources to help each of us from reinventing the wheel throughout the year. If you're not familiar with the next generation of My4H site launched in this past March, go to the site and search the tag My4H Tools. You'll find resources to help you get started with the site, including a My4H orientation webinar. On behalf of the NAE4-HA Geospatial Task Force, I'd like to thank you for joining today's webinar, and special thanks to Frank for presenting today. We invite everyone to join